In this video, we're going to talk about a scientist named Amos Emerson Dolbear, who lived during the 1800s. And he was very curious about the sounds of crickets, and he wanted to study their chirping. He had questions like, why do some crickets chirp more than others? And what influences a cricket's average number of chirps per minute? Well, we're going to explore some of his questions in this video. So Dolbear took these questions and he went to go observe these field crickets. Here's a little picture of our field cricket. One thing he noticed when he was observing these crickets in nature is a pattern between the temperature outside and how much these crickets were chirping. So for example, he noticed that when it was 70 degrees Fahrenheit outside, that he counted 120 chirps per minute. And I'm going to use that little symbol, C per M, for chirps per minute. He also found that when it was, for example, 42 degrees Fahrenheit outside, the field crickets were chirping 8 times per minute. So if you're paying close enough attention, you'll notice that there's a pattern between the temperature and the average chirps per minute. In these lower temperatures, like 42, we have something like 8 chirps per minute, 20 chirps per minute. As we get into the higher temperatures, like 70, we'll have 120, and even when we have 60 degrees Fahrenheit, there's 80 chirps per minute. So we have this relationship, and we actually call this a linear relationship. We're going to take a look at a graph of this data. We're going to plot this data on a graph and see what it looks like, and you'll see this linear relationship. Here I've plotted some of Dolbear's data onto a graph. We have an x-axis that shows chirps per minute, and we have a y-axis that shows temperature in degrees Fahrenheit. Let's check one of these data points to make sure this graph makes sense to us. Let's take this second one where Dolbear counted 20 chirps per minute when it was 45 degrees Fahrenheit. Well, let's look at the graph. 20 chirps per minute. This is our data point here for 20 chirps per minute, and looks like we're at about 45 degrees Fahrenheit. And you'll notice this graph makes sense because when we're at fewer chirps per minute, looks like our temperature is lower. When we're at more chirps per minute, looks like our temperature is higher. So this graph makes sense with the data that Dolbear collected. One of the important math skills that Dolbear had to have to make something out of this data is he had to be able to find an equation that represents this relationship that he found. The graph does help us. We could use this graph for some estimation. If we, counted that there were maybe 60 chirps per minute, we could estimate. We could look at the graph and say, okay, it's probably 55 degrees outside when those crickets are chirping 60 times per minute. But if we find an equation, that gives us a way of determining a number, a specific number, not just estimating using a graph. Dolbear found an equation for this linear relationship, and he called it Dolbear's law. And Dolbear's law says that T, if T is the temperature in degrees Fahrenheit, is equal to 50 plus the difference N minus 40, if N is the number of chirps per minute, N minus 40 all divided by 4. We're going to do an example problem that's going to show us just how valuable having an equation for this relationship is, rather than just having this graph to look at and make estimations from. So the problem asks us approximately what temperature is it outside if a field cricket is chirping 76 times per minute. Well, our first idea might be to look at this graph and see, okay, chirps per minute, let's find 76. That's going to be somewhere in here. We're not sure exactly where. And we could make an estimation saying maybe it's, 57 or 58 degrees outside, but we don't know for sure. So instead, we're going to use Dolbear's law to help us determine exactly what temperature it is outside if a cricket is chirping 76 times per minute. So that's our important information in this problem, is we have a cricket chirping 76 times per minute. And let's remember that times per minute is this N in Dolbear's equation. So all we're going to do is use Dolbear's equation and plug in 76 for N. So we get T is equal to 50 plus N minus 40, which is actually going to be 76 minus 40, because we plugged in 76 for that N, all divided by 4. And if we simplify this a little bit, we'll get that t is 50 plus, now in the numerator we have 76 minus 40, which would give us 36. And 36 divided by 4 is 9. So I'm just going to put 9 here. And then simplify a little more, and we have t equals 50 plus 9, 59.